Okay, so we are going to begin Chapter 3. Chapter 3 is going to be a lot of fun because we get to do some graphing. Yay, graphing. So we're going to start off in section 3.1 and we're going to understand a few components of graphing and coordinates and how to identify certain aspects so that we know what we're doing and we become professionals in discussing relations and graphs and how algebraic expressions can be expressed up in picture form, essentially. So again, we'll begin with section 3.1. We're going to be starting off with discussing what a Cartesian plane is. And our Cartesian plane is what we graph on, and it's basically comprised of two lines. One is horizontal, one is vertical. Okay, the horizontal is the one that goes back and forth, and it is the x-axis. The one that goes up and down is vertical, and that is the y-axis. So that whenever we plot points, we will have to know how far to the right or to the left on the x-axis we have to move, and how far up and down on the y-axis we have to move to be able to get beyond just these lines, but all over the entire plane. If those who have taken geometry, do you remember what defines a plane? Anybody? Anybody? Is it 2 points? Any 2 points define a plane?
Yeah.
Or does that define a line? Any 2 points define a line. Any 2 lines define a plane, right?
Yeah.
And then a plane is comprised of what? 3 things. 2 what? 2 half what? 2 half planes and 1 line. Y'all remember that? Man, you are so smart. All right, well, we have a plane, and so if you think of plane, it is more than just a line. It is an entire area, 2-dimensional area that we're going to be working with. Now, with each axis, we have a positive and a negative side. And we'll talk about that first, and then we'll begin to talk about the coordinates. We have a positive side, so if you think of a number line that we've looked at before, then that is the x-axis. Okay, your typical number line that we've used in the past is your x-axis. So we have a +1, +2, +3, and so on. We also have our -1, -2, -3, and so on. Now we also have a number line for the y-axis, but it is rotated 90 degrees. Up is the positive direction, 1, 2, 3, 4, and so on. And then in the down direction is negative. -1, -2, -3, -4, and so on. You continue however far you need to go. Okay? Just like number lines, you can number this in any manner that is easier for you. If you want to do it by 2s or 5s or hundreds, that's fine. Whatever works best for you. Now, we have 4 quadrants. Quad meaning 4. So we would have 4 sections within our Cartesian plane. We start here, and this is 1, 2, 3, and then quadrant 4 over here. Make sense? Any questions or concerns with that? All right, now, again, what we are doing with this is we're going to take an algebraic expression which usually is going to involve a y and an x. Okay, we've done algebraic expressions like x + 5 = 6. Okay, we are now going to incorporate another letter with that, and it will be y + 3x = 18, something like that. Okay? So then whenever we end up solving for this equation, we are going to be able to solve for y, figure out what y is, but then also solve for x, figure out what x is, and once we know our x and we know our y, we're able to plot our points. But why are x and y important with this, with the Cartesian plane? Well, whenever we have our x value and our y value, that gives us our coordinate points, which would be here. If we have 3, positive 3 for the x, and then negative 2 for the y, this is how it would be written. Okay, you have your 3, which is listed first, and then your y, which is listed second. Also known as your domain and range. Raise your hand if you can tell me which one stands for the x. Is it range or is it domain? You can look in your books if you want to. Which one actually stands for the x value? Is it range or is it domain? Anybody? Domain. Perfect. Thank you very much. The x value is the domain. Domain equals x. Range equals y. Just memorize that. Because if you were given a list of domains, so if it says your domains are 7, 19, -2, and let's say that's all they give you. Well, all of those are x values. Okay, and then they say your ranges are -1, 4, and -21. Well, those are your y values. Okay, now let's talk, before we talk about combining these, whenever we have multiple ones listed, let's talk about how we can take one set and actually plot it. Most of y'all should have done this sometime in the past, but we'll go over it just to kind of refresh our memories. So we have our domain, our D, and then our range, our R, listed as our x and our y. So we go +3, 1, 2, 3 on the x-axis, and then -2, 1, 2 on the y-axis, and we plot our point right there. And that's how we're able to plot one point that we were given for our domain and our range, or our x and our y. Now, whenever we have multiple values given, then you would plot, it would be 7 and -1. For the first one, the first two, it would actually be listed like this: 7, -1, 19 and 4, and then -2 and -21. So we have 7 and -1, 19 and +4, and then we have -2 and -21, which would be down here. And if these were values given from one particular equation, then we would actually be able to connect these in one continuous line, and we would be able to look at this and collect information from it. Okay, so if, well, just keep that in the back of your mind for right now. Any questions with plotting points or understanding what domain and range are and how they apply, especially whenever we are given various different pieces of information? Because sometimes you will be given these. These are coordinate points. Sometimes you will be given a list of your domains and ranges. Sometimes you'll have a combination of it. You're going to have to decipher between it. Are there any questions about that? Easy? Yeah, kind of. It really is. And it's actually kind of fun because you get to draw. and takes you back to the day of Chili's whenever you're drawing the dinosaurs and everything. Unless you don't like Chili's, you can eat somewhere else if you want. All right, now what we're going to talk about is a relation. Okay, a relation is a set of any ordered pairs. Okay, a set of ordered pairs. This is kind of a broad definition or concept, but if you just understand a relation as just simply being ordered paired, a set of ordered pairs, then it'll kind of funnel you into understanding the concepts that we're about to jump into. In order to take coordinates, let's say we had 5 and 2, we had 3 and -7, and then -2 and -2. Another way of looking at this with regard to relations is if we were to separate them separately and see how they apply. So we can do 5, 3, and -2 in our x's, and then our y's can be listed as 2, -2, and -7. Now, as we were given in our list here, the 5 goes to the +2, the 3 goes to the -7, and the -2 goes with the -2. So we can see what kind of relation is taking place between these lists of ordered pairs, or this group of ordered pairs. It's another way of visually being able to see what's taking place. Any questions about that? So what were to happen if we had a list, if we had this? We had 2 and 5, 3 and -1, -1 and 4, -1 and 4, and then 2 and -6. On your pieces of paper that you have on some scratch paper, map this list of ordered pairs like this. And let's see what happens. Okay, so you'll draw 2 circles. You have your x, and you have your y, x and y. List your x or your domain here, okay, and your ranges here in the y. It usually helps if you do it from in order, but you don't necessarily have to, as long as you're connecting the right ones to the right places. Let's see what we come up with. Yes?
If they're all like, if you put the x's in the order and the y's in the order, wouldn't it just all match up like on the same line?
It's possible. It may be just lines going straight across. It could be in this circumstance because we went from greatest to least, and so they end up connecting.
Does it have to be like that?
Nope. There is no requirement for it to be directly straight across. Think of it as a multiple choice question, or matching question, I mean. So you have your list of questions and you have your list of answers, and it just tells you draw a line to the correct answer. That's all you're doing here. Sometimes it may go across, sometimes it may go diagonal. So, now, one thing I will say, because y'all may have done this a certain way, so I'm going to have y'all correct it if you did it incorrectly. Here, we have 4 ordered pairs. If we notice in the x, or the domains, we have a 2, positive 2, positive 3, negative 1, and then another positive 2. We only list them once. If they're listed, if there's more than one of, or if they're repeated, you still only list it once. So we will start off 3, 2, and negative 1. Our y, we have 4 individual values. So let's go ahead and write that. 5, 4, negative 1, and negative 6. Okay? If you did have to correct it, now that we've corrected it, draw your lines the way you think that they would go to where they are matching to the correct place. Which is interesting because there's 3 here and 4 here. So how do you think you would do that?
Do they have to be greatest to least, or can they be least?
They don't have to, but whenever you organize information, it helps. But no, it's not like you're going to, you've broken all the mathematical rules by not listing them in order. As long, it just helps you kind of coordinate through things, but no, you don't have to. Okay, so now that we've done this, let's see what we have. We start off with our 3, and it goes to negative 1. All right, so we've got that one taken care of. We have our 2. Well, this 2 goes to positive 5. Got that one taken care of. We have negative 1, and it goes to positive 4. All right, we have that one taken care of. Well, here we have 2, and it goes to negative 6. Well, we've used 2 already. We just so happen to know that there's going to actually be 2 of them. So, still from the same 2, we go to negative 6. Okay, yours may have looked like this. You may have had 2, 3, negative 1, and 2. And then 5, negative 1, 4, and negative 6. In which case you have 2 with 5, 3 with negative 1, negative 1 with, oh, I'm sorry, you don't repeat it. Negative 1 with 4, and then 2 with 6. So yours may have looked like this, and that is absolutely fine. There's nothing wrong with that. All I care about is whatever works and helps you visually, do that. Okay? Whatever makes it easier for you. Now, does anybody know if this is a function or not a function? Does anybody remember from Algebra 1?
It's not a function.
It is
because something repeats twice.
Exactly.
And
Yes, we're about to go over that here in just one second because it goes into section 3.2, but there's a term called a function, and we're going to be hearing that word a lot throughout this chapter. Well, I'll go ahead and explain it now, actually. A function is whenever one and only one domain is matched with one y value, okay? So let's think of it as boys and girls, okay? Boys and girls. Boys are x's, girls are y. One guy can only date one girl, okay? Otherwise, it's bad. It is not a function, okay? So here, number 2, well, he's dating number 5. Well, he's also dating number 6, or number negative 6. Okay. First of all, he's going to get in a lot of trouble. Okay, but it is also not a function. It is, if you want to think about it in terms of it's not okay. Now, as we will soon learn, it's okay for this to happen. we are given values of, let's say this was reversed. We have 5, -1, 4, and -6. And we had 2, 3, and -1. So we have 5 and 2, -1 and 3, 4 and -1, and then 2 and -6. Okay, one girl is dating 2 guys. Well, evidently that's okay. That is still a function. Okay, or it is a function. It is not a function when a guy dates 2 girls. So know the difference between the two. There cannot be 2 x's, or there can't be a 1x that is paired with 2 different y's. Okay? Otherwise it is not a function. We're going to learn other ways to find out if something is a function. We will understand what function even means here in a little bit. What's important right now is being able to understand your list of ordered pairs, which one is your domain and range, and how they have a relationship with each other. Okay? Does everybody understand this part of things so far? How to draw this, and then what we do, I'm going to erase this part, we can take this same information and plot it on a Cartesian plane. We can have 2 and 5, so 2 and 5, say right here. 3 and -1, 3 and -1. We have -1 and +4. And then we have 2 and -6. Some people may think, well, we're just going to repeat itself, but we're really not. You know, it's going to end up on the same dot, but it won't. We're only moving over 2, but instead of going up 5, we're now going to go down -6. So this is how we would plot this on the Cartesian plane. Okay, so let's do this. 1, 2, 3, and so on. Now, another way, well, we're going to stop right here, pay attention to this and where we're plotting, and we're going to talk about functions some more, and another way that we can determine if something is a function or not. All right, so let's go to 3.2. 3.2. If we read our definition down at the bottom of page 92, a function is a relation in which every domain element, which is the first coordinate, or the guy, is paired with one and only one range element, or the second coordinate, or the girl. Okay? So, if we look up at the 2 examples up above, okay, on the very top of our book, what we can do is what's called a pen test. Take your pen or pencil, lay it flat on the far left side of the Cartesian plane, and then move it across. And you can, what'll probably help is if you go slightly underneath, because this is a small picture. As you move it across, if you think of a line going all the way up and down your page as you move it across, if it touches one and only one dot at a time as you move from left to right, then it is a function. Okay? Compared to if you go do that on the second one, do just underneath, and again, imagine a line going all the way up and down your paper and you're sliding it across. Is this a function? No. We find out 2 areas, 2 points, where it actually touches 2 points at the same time. At -1 on the x-axis and at +2 on the x-axis. Okay? Which is interesting because we're only moving along the x-axis to see where there are 2 of them. What that means is we have, for the x-coordinate on the second one, we have -2 and +2, -2 and -2. So notice we have the same x or domain values, but this same guy over here is hanging out with a 2 and also hanging out with a -2. Okay, those end up being plotted here, essentially here and here. The same thing happens whenever we go in the +2 direction. We have a +2 and a +2, and then we also have a +2 for an x and a +1. Okay, so it is not a function. Is this a function here with this information that we had earlier? Is this a function or no?
What? Which one?
This one here, our first one that we started and we now plotted here. No, again, because we have a 2 and a 2, the same 2, 2 is hanging out with 5, 2 is also hanging out with 6. And even if we do our pen test, at this point right here, that line ends up connecting 2 points at the same time, so we know that it is not a function. Sound good? Easy enough, right? It's not hard to determine if that is. So that's 2 different ways that we can figure out if it is a function or not. Depends on what we're given. Look on example number 1 and answer this. Which relations are functions? Now, f, whenever it says f equals, then that's giving you a list of coordinates. And then g equals, it is a different relation with a list of coordinates. It's just identifying 2 different relations. So look at those and determine if which relations are functions. Is f a function, and is g a function? So you'll look at that real quick and see what you come up with. So what do y'all think?
F isn't G.
Okay. Anybody else? What do you think? Who thinks f is? Raise your hand. You think f is a function? Backing out of your question? Oh, peer pressure set in because everybody turned and looked at you. What are you thinking? I misunderstood the question completely.
I did. I was thinking of.
So then, how many of you think that g is a function? Okay, absolutely. All right, so f, obviously we see that there are 2 3's, or I'm sorry, there's 2 3's listed, but that same 3 is partnered up with 2 other numbers, okay? So it is not a function. Now, I'm going to read this one paragraph on page 93. It says, sometimes functions are described by rules. In this case, range elements depend on the value of the domain element. Therefore, a variable that represents a domain element is an independent variable, and a variable that represents a range element is a dependent variable. Now, that's all good and fine. You don't necessarily have to understand what that means in verbiage. We're going to understand what that means with letters, numbers, and operational signs. So what's most important is understanding that the statement below it, the mathematical statement, it says f of x, or f, the function of x equals, was it 2x plus 3? 2x plus 3. All right? All this means is the f of x, or the function of x, we replace that with a y. and we have 2x plus 3. This is just something that you have to memorize. Okay, you have to just come to terms. Whenever I see this, I will take this out and I'm going to put a y in its place. And this is what we're looking for. This is absolutely what we're looking for. So here, what we get to do now is figure out how we're going to find values of y and x that would make this statement true, and we get to plot those on the Cartesian plane. So we're going to put we'll put our plane right here. And what we're going to do is put this little thing like this over here. I want everybody to make one of these. Yes. We are going to have y, well, we can do this. We'll have x over here and y over here. Underneath, we're going to list values of x. Underneath, we will discover what those values of y will be when we have values of x. When we are given just this statement, this means we get to do whatever we want to, okay, which is fun. We get to pick whatever value of x that we want to make our life easy and solve for y. There are other times when you will be given a list of 3, 4, or 5 ordered pairs in which you plug them in and find out if it's a true statement or not. You may be given just a list of domains. It'll say domain equals, and then you have 1, 7, 9, and so on. Well, those are your x values, so you plug in 1 for x and solve for y. You plug in a 7 for x, you substitute and figure out what y is, and the same thing with 9. Now, if y'all don't remember about that, that's okay, because we're going to go through it again. So let's start off where we're just given this, and we are going to come up with whatever value for x we want to. What do you think is typically the easiest integer or number to plug in for x and solve for y? You're like,
1.
1 is a good one. 1 is a good one. I think, personally, I think there's one that's a little bit easier that I like a lot. But let's do this. So we have 1 for x, so let's solve for it. Y equals 2 times 1 plus 3, which gives us what? 5. 2 times 1 is 2, plus 3 is 5. So our y value is going to be 5. What we have just done is found a coordinate. Okay? We have found the coordinate of 1 and 5. So we'll list some other ones. What happens is whenever we correctly solve for this equation multiple times, when we plot it, we end up with a line going some direction on our Cartesian plane. Okay, so that's why they call this a linear equation. A linear equation. All right, so let's do another one. What do you think is another easy number to put in for x to solve for y?
0.
0. 0 is my favorite one. So here we plug in y equals 2 times 0, which is what? 0 plus 3. We didn't even have to add anything. So when x is 0, y equals 3. So our next one is going to be 0 and 3. All right, somebody else pick one more value for x. One more value for x.
2.
2. We will do 2. So 2 here, we have y equals 2 times 2 plus 3, which equals what?
7.
7. All right, so when 2 equals x, y equals 7, and we have our other coordinate point of 2 and 7. So let's plot these. We have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So we have 1 and positive 5, 0 and positive 3, 2, positive 2, 1, 2, and positive 7 up here. So, how many do you think we need to have in order to have an accurate line drawn?
2.
2 is the bare minimum, okay? So what do you think having 3 might help us with? If we were to say, let's do one more, what does that kind of do for us?
Almost establish which way it's going.
That helps. I mean, you can still do it with 2, but whenever we have a third one, it kind of confirms that we're on the right track and we didn't make a mistake. Because if you have your 2 here, but then we found 1 was way over here, we did something wrong. And so we need to go back and double check each one that we did. So we need to have at least 3. You can do more. And what's interesting is whenever we draw this line, we connect all these dots and we continue going. No matter what value we plug in for x, whenever we find y, it will land somewhere on that line. It's the beauty behind it. You can pick some number like negative 1,560,000,000 whatever and find the value of y, it will land here. Well, what if we determine a value for y and figure out what x is? Will it still land on the same line? Absolutely, as long as you did your math correctly, it will. So this is our linear equation. Y equals 2x plus 3. This is what it looks like. It will be a line going in this direction. Sometimes it may be helpful, depending on what you're trying to establish, to choose a negative number. Let's do -1 and figure out what this is. So y equals 2 times -1 plus 3, which equals 2 times -1 is a -2 plus 3, which just gives us 1. So we have -1 for x and +1 for y. Well, it still lands on that same line. Okay. Sometimes they may be asking you, what value or values for this linear equation fall within coordinate number or coordinate 2. Okay, well, this coordinate here fits that. Okay. Are there any questions with that so far? So, whenever we have this and we're given nothing else, we get to make up whatever numbers we want to. In this situation, we have to plug in 1 for x. So basically, what we have here is we are told x is going to equal 1, 7, and 9, and we have to plug in each of those into the equation and figure out what y equals, and then plot those on the Cartesian plane. Easy enough? Yes?
So if it gives you the domain, like the 3 numbers, you have to do those. But if
Yes.
it doesn't, you can do whatever.
That's absolutely true.
Okay.
Yep. Now, and I don't think you're going to see this, but let's just say here's 3 of them, but we want you to find 5. Well, then you have to use these 3, and then you can make up whatever numbers you want to figure out a 4th and a 5th coordinate point, but you won't see that issue. But yes, if it's just this, you get to pick whatever numbers you want to, and I love questions like that because I love making math as easy as possible for me. All right? Any questions with this so far? All right, good job. Good question, by the way. All right. We jumped ahead a little bit. But let's go ahead and move to 3.3. Now, if you look at the top of page 100, it will say the equation 2x minus 3y equals 6. 2x minus 3y equals 6. Okay? This is what's considered the standard form for a linear function, okay, or a linear equation, the standard form. Now, the equation that encompasses all possibilities is given right next to it, which is ax plus by equals c. Okay, where a, b, and c are going to be all elements of real numbers. Okay, they are all going to be real numbers. Now, what's interesting is there's a difference between here and here because it's saying, well, it says you've got to add right here. But this equation says we're subtracting. Well, what is the actual value of b in this equation to make this correct? A negative what?
Number.
Right. Well, what? Negative 3. Okay. So they're kind of throwing in a couple of learning opportunities with this, where we are still doing 2x plus a negative 3 times y, and it equals 6. So here our a is 2, our b is negative 3, and our c is 6. Okay, so even though it's saying subtract, that just means that b is a negative number that you're adding. And whenever you add a negative number, you're subtracting, if you'll remember that from pre-algebra. So this is our standard form. This is the form we're trying to get into. Now, what's interesting is, I say interesting, what our goal is in order to make life a little bit easier for us to graph it, we want to move these around so that y is by itself. So what we will want to do here is go back a little bit, we're going to subtract ax from both sides. So we end up with by equals c minus ax. And y needs to be by itself with nothing attached. So we're going to divide by b on both sides so that y equals c minus ax divided by b. If this is kind of confusing right now, don't worry about it. It will make sense here after a while, especially whenever you use a's and b's, things that stand for other numbers. It can be kind of confusing. We will actually apply this a little bit more later. But understand that c is a number, a is a number, and b is a number. The only letter that we won't know are letters are y and x. And it's important that we want to solve for y so that we substitute information into x. Make life easier for us, and then we can graph it. So let's see how we can do this. Let's look at example number 1. We have this given for us. So let's break this down. We have this equation as example number 1. Let's move everything around so that y is by itself. We're going to subtract 2x from both sides so that minus 3y equals 6 minus 2x. Well, now we have to have y by itself. Y needs to be a positive number. So what we're doing is dividing by negative 3 on both sides. So that y equals negative, we'll do this. We'll break these up into two fractions. So we have negative 6 over 3 plus 2x over 3. Now the reason why this one's positive is because we have a negative 2 over a negative 3, which gives us a positive 2x over 3. Does everybody see how we got to that? Okay, good. Here we can actually simplify where y equals negative 2 plus 2x over 3. All right. Now what we have is this equation, and we've got to figure out values for x so that we can solve for y. Values for x so that we can solve for y. So let's do that. We need to find at least how many of them?
At least 2, but 3 is the best to do.
Yes, so we can now adjust our answer to at least 3. Yes. So, and what I'm asking for is that y'all find at least 3. You can be overachievers and find 7, 8, 9, whatever. In fact, we will find a little bit later on in this class where we're going to be graphing functions that we really need to have 5 to confirm what it is that we're looking at. So, somebody pick a number that you would like to use for the value of x. Since we know how we got here, I'm going to rewrite this up top. Y equals, we'll do it this way, 2x over 3 minus 2. Okay, so somebody give me a value for x so that we can solve for y. What would you use?
0.
0. Okay, so let's use 0 for x and work through this. Y equals 2 times 0 over 3 minus 2. So what does y equal? Oh, you had them smarts a minute ago, but what happened to them now? Confusion sets in. Well, now there's a 0 up top. What can I do with that? Without your calculator, what is 2 times 0 divided by 3?
Oh.
0.
0.
Are you sure?
No.
So this is what confuses people, so we'll actually go over this so that we can reconfirm it. Can we solve this? And can we solve this?
Yes.
Can we solve the first one? Can we solve the second one?
We can.
Since you've put your calculator underneath the table
It's all.
to try to be sneaky about it. So can we solve the first one? 0 divided by 3. It's just 0. What is this one? 3 divided by 0. What is that? Did you do it on your calculator?
I didn't have.
Do it on your calculator, see what happens. Seriously, go
It
ahead.
can't be done.
Yeah. This is.
So what's that called? Do y'all remember?
Error?
Yes. If you try to do that on your calculator, it will show up as an
It
error.
didn't work.
It is called undefined.
This is math errors.
Lindsay, calculator didn't work. You were supposed to help us.
So y would equal -2.
Yes, so in this situation, y is going to equal -2. This is very, very important because if this were switched, just kind of as a sidebar, if it was 3 over 2x, we would not be able to use 0 because we would not be able to calculate it. Okay, it would be undefined. So those are one of the circumstances where 0 wouldn't be a good number. In fact, you can't use 0 to help it figure that out. Which is good that we went over this. So 0 gives us -2. Somebody else pick another number.
7.
7. Ooh.
Wow. I've had that one sit in my head all the
All right, so you get to do this one then.
I need some numbers.
7. X equals 7. So here we have y, because we're going to learn a lesson from this one. 2 times 7 divided by 3 minus 2. So y equals 14 over 3 minus 2. So what now? What does y equal?
5.
Well, we have to find a common denominator for both of them now. So y equals 14 over 3 minus 6 over 3. Because in order for this to have a denominator of 3, we have to multiply the top times 3 now, which gives us 8 over 3. So now we get to plot a fraction of 8 over 3. Okay, understanding this, somebody different give me a number. Are you still happy with your 7? Yeah, well, you're just going to commit to it. I'm not going to say no. Somebody else give me a number. So let me ask you this. What series of numbers do you think you would want to stick with in this particular situation, and why?
Even.
Huh?
Even numbers.
Yes, but there are some... None.
You could do like ones that are multiples of 3.
Yes, you want to pick numbers that are multiple of 3. Okay, and we'll talk about why this is important. You can actually pick numbers, since we're given whatever, we get to choose whatever numbers we want to. You want to pick a number that whenever you can simplify it, gets rid of that denominator completely, so that you don't have to mess with fractions anymore, because you get to pick them. So how about we use 3? Let's use the number 3. Whatever that denominator is, that's an easy one. So y equals 2 times 3 over 3 minus 2. Two ways to do this. You can either cancel these out, or you can actually calculate it. It's 6 over 3 minus 2, which equals 2 minus 2, which equals 0. Okay, that is a whole lot easier to plot and figure out, and we got through it a lot faster. Somebody pick one more number for me. What number would you use to try to set it up to where you're automatically eliminating that denominator?
81.
81. That's true. 81 is divisible by 3. So you want to come up and...
No.
Yeah, I didn't think so. So y times 2 over 81 divided by 3 minus 2. Well, 3 goes into 81 27 times. And so equals 54 minus 2, which equals 52. So when x equals 81, y equals 52, and we will have one particular student that gets a negative score on their homework.
And gets to graph it all for us.
So, does this make sense? This is a great, great learning opportunity of, it's not that you just pick a number, but pick a number with a purpose. Okay, and you begin to mentally start working your way through some of these equations. Now we have our list of coordinates, and we can begin plotting them and watch them all land up on the same line. If they do not, you made an error somewhere. Let's say we plot this one, and this one, and they're on the same line. This one is off. What that means is chances are we calculated this one incorrectly. If our other 3 or 4, however many we're required to do, if they all land up accurately, but there's one off, then chances are we miscalculated that one. So go back, double check that one, and see if there's a change to it. Any questions? Awesome. Now, whenever we graph these, we have what's called a slope of a line. A slope of a line. And we're on page 101 now. The definition of a slope of a line is the ratio of the change in y values of 2 points on a line to the change in x values of 2 points on a line. So, if we look down at the bottom of the page, we are given that slope, which is denoted by a lowercase m, equals change in y over change in x. Is that correct? So, what is another way of saying change in mathematical terms?
In physics, the triangle.
Oh, change is triangle?
It's like the science of
Oh, yes, you're correct. It's like, that's obscure. Whenever you think of M, what do you think of? Ball. It's, okay, that's good for you. But yes, in physics, the symbol for that is, I see where you're going with that. Here, a little bit more simply, change is difference, which also means what? What is difference? Add, subtract, multiply, divide, which is it? Subtract. Okay. So, what we are doing, if we have 2 points, we will take y2 minus y1 over x2 minus x1. And we will be given some sort of fraction. And again, remember, fractions are ratios. Okay? So, when we're talking about the ratio of the change or the difference in 2 points, 2 y points, and 2 x points with relations to those 2 original points. So let me say that differently because I said points like 18 times. So if we have, well, it gives us 4 and negative 8, and then we also have 1 and 6. Well, we will calculate this out as 6 minus a negative 8, which is actually plus 8, over 1 minus 4, which gives us a negative 14 over 3.
Wait, why would the 1 come first?
Good question. Why does the 1 come first? I asked you. The 1 comes first down here because we have to be consistent. We're talking about the second point, okay, first, so which is 6, and then it's over the second point of x. So since we started off with 6 for the y, we have to start off with 1 for the x down here. So it's the second point over the second point, second y over second x, first y over first x. Does that make sense?
Yeah.
Now, what's interesting about this is standardized, y2 minus y1 over x2 minus x1. What if we started with 8? Let's finish this out. What if we started with 8? Okay, I'm sorry, it should be negative 8. If we started with negative 8, well, that's the first point. It tells us to start with the second point.
Add it.
Well, what comes next? We have this point minus this point minus the other y. Now we have to stay consistent. So since we started with negative 8, we have to start with 4 minus 1, the second point. Well, that gives us, I'm going to skip boards over here. We have minus 14 over 3. Well, that's what we had here.
No,
Okay.
it paused.
Huh?
Oh, it wasn't.
What's interesting about this is we were given 2 points. Did they tell us which one was the first point and which one is the second point? No, it doesn't matter. The slope is the slope whether you start up at this point or you start at this point. Okay, the slope is still going to be the same. What's important is the consistency. So you asking that question was a very good question. Okay, if we start with 6, the last point, we have to start with the x in that same coordinate set. Okay, so we start with 6, we have to start with 1. Then we go to 8, the negative 8, and then the 4. Here we started opposite. We started with the negative 8, so we have to start with the 4 on the bottom. Okay? As long as you are consistent with those, you will end up with the same answer. That's why they don't say this is the first point and this is the second point. It doesn't matter. Everybody understand? Cool. Where you will most likely end up making mistakes is the application of your negative signs. Pay attention to those. Okay, because that's where people typically mess up. They will forget to bring it over. They will forget to change them correctly. So just be mindful of that. All right. Go ahead and move over to 3.4. 3.4, finding equations of lines. Finding equations of lines. Now, we've talked about where we have y equals 2x plus 4. Okay? We were originally given where y minus 2x equals 4, and we changed it over to where y is by itself. When we move it over to this form, where y is all by itself with nothing attached, okay, this is called what? Read your book real quick. What's it called? Page 105. Who can see it? What does it look like? You don't have to be sneaky. I'm telling you to look in your book. And people are like, no, look in your book. It's okay. What's it called? Whenever it's in this format, what is that called? Slope what?
Intercept.
Slope-intercept form. Yes. Slope-intercept form. So we have, now this is the generic term because y equals mx plus b, okay, which means that we have variables that can change. We can have different amounts for them. Okay, y and x, we know we're trying to solve for those. Earlier we found out b, okay, is just some letter, okay, or some number we don't know a value for. Earlier, we found a equals something, b equals something, c equals something. Okay, well, we don't have an a and a b, or an a and a c, we have a b, but why do we have the letter m? Why don't we have a or c? What is m? What did we just learn? Huh?
Change line.
Yes, the slope. Okay, so if we have this, m equals 2. We don't have to figure out the slope. When we have this equation, we know what it is. Or if we want to talk about it in ratio forms, it's actually 2/1. So when we have this equation, this, and it's telling you to find the slope, we're like, oh snap, that's easy. It's 2. So m equals 2, and you're done with that question. So slope-intercept form, y equals the slope times x plus b. So what if it was y equals x plus 4? Well, the 2's gone. What's the slope now? So what would be the slope? 1. Very good. Because when there's nothing in front of the x, we can easily assume that, or not assume, but we know that it is a 1 in front of it. We just don't show it. Okay, so in this instance, the slope is going to be 1, or m equals 1. So there we have our slope-intercept form. Now, whenever we have it in this form, we can find the y, what's called the y-intercept. Okay, the y-intercept. The y-intercept is going to be whenever we have a line, we have our x, we have our y, at what point on our line does that line hit the y-axis? Okay, at what point does that line hit the y-axis? What is the value of 0? Well, I just gave it to you. What is the value of x when the line hits y?
0.
0. Man, you are way ahead on that one. Didn't expect y'all to get it. So, yes, if we look, when this line hits y, x is 0. Okay, so what that tells us is if we have y equals 2x plus 4, well, we know that x equals 0 if we're told find the y-intercept. Let's go over here, do this little thingy. Well, to figure out the y-intercept, we know x is 0, so we have to figure out what y is when x is 0. So then we plug this in. Y equals 2 times 0 plus 4. So y equals 4. So on this equation, in the slope-intercept form, the slope is 2, m equals 2, or in ratio form is 2 over 1, and the y-intercept is going to be 4. And again, you figure that out by putting the value for x as 0, because x must be 0 for it to hit the y-line. So it will be 0, and then 1, 2, 3, and look, we were right. Y'all got how I could like space these however I wanted to make it true, right?
Yeah.
So. Oh, we're past that. Does everybody understand that? Okay, so we can find the slope and we can find the y-intercept. What do you think the x-intercept would be? How would we figure that out?
That one, I think.
Sure. What would be the x-intercept? How would we figure it out? Huh?
0.
No,
What's 0?
X. Oh, the X.
Wouldn't it be 4?
How do you figure it out? What's the first thing you would do?
You change the equation to equal x.
Okay, so we can do that. So we will do y minus 4 over 2 equals x. Okay, so we've done that. So how do we find the x-intercept? Y'all are making this so much harder than what it is. And I see a lot of y'all drooling on yourselves. Oh. How did we find the y-intercept? I don't remember it, which is amazing because we talked about it like literally 3 minutes ago. How did we calculate the y-intercept? What did we do? What was 0? X. When x is 0, that's where the line actually touches y, the y-axis. Okay? So we knew to plug in 0 for x because x has to be 0 in order for that line to hit the y-axis. How would we find the x-intercept?
0 for y.
Yes! Perfect! So in that situation, we're going to make the value of y 0 because y has to have a value of 0 for it to hit the x-axis. The coordinate point is going to be something in 0. So if you need to find the x-axis, put 0 for the value of y and solve for x. Make sense? It's the same thing, no matter if y-intercept, x-intercept. If you're looking for the x-intercept, y is going to be 0. If you're looking for the y-intercept, x is 0. And then you just solve. Easy enough, right? 0 is one of your favorite numbers whenever trying to find the points for an equation. When it tells you find the y or x-intercept, you gotta be like, yes, I get to use my favorite number, 0. I get to plug it in. So it's like crazy easy for you. don't think of it as something that's difficult because it's fun. You get to use 0. Everybody smile and say, yay, we get to use 0. Yeah, nobody did it. Alrighty. Now, whenever we were talking about the slope earlier, we have m equals y2 minus y1 over x2 minus x1. You will be asked to figure out what the slope is. Sometimes you may be given 1 point and the slope, in which case you have to move this equation around and solve for the unknown. Does that make sense? So if you know certain points, you may end up having to change this to where here we're dividing by this. So now we have to multiply both sides to where you have m times x2 minus x1 equals y2 minus y1. Okay, and you may be given a point, whether it be 3 and 5. So then you can plug that in to where m equals 3 minus x1, and then 5 minus y1, and begin solving from that direction, especially if you are told m equals 4. So in this case, 4 times each of those. And then begin solving from that point. You can still find out information if you have 2/3 of it. If you have 3 pieces and you know 2 of them, you can find the 3rd. We kind of learned that from like our distance equations, things like that. If we know distance and time, we can find rate. This is the same thing. So I bring this up because it's going to kind of take what you already know and mix it around a little bit. Okay? All right, real quickly. We are on section 3.5. I'm going to go over this really quickly. But the section is called special function. We know what are special functions. We remember what a function is. Okay, we will remind ourselves that a function is a relation in which every domain element is paired with one and only one range element. Now, there are certain instances whenever we're given information and we automatically know what it will be. Okay? For instance, on page 111, the first Cartesian plane that we see, that equation is x equals 3. X equals 3. All that is going to be a vertical line when x equals 3. So it will just go straight up and down. A lot of you may think, well, we just plot it on there. Well, it's actually all information going up and down at that point, at point 3. Okay? Whenever y, in this particular situation, equals 4 on the second Cartesian plane, then we will move up to the positive 4 on the y-axis, and then it will be a line that goes horizontally from right to left. Okay, so there's nothing really that you have to figure out or calculate. You can recognize that as a special function. You just see y equals 4, well that's easy. I go up to 4 and I draw a line going straight across. Make sense? not having to calculate anything ought to put smiles on your face. So that's really simple and really easy. Another one, which is interesting, is whenever we have a function of x. Remember that whenever we see this, what do we substitute for that? What letter? Y, absolutely. But whenever we have a function of x where we have the absolute value of x, how many answers will we have for x whenever we solve? Typically. 2. Why? We have a negative and positive because we're talking about distance. So what that means is whenever you plot this information, let's say it began here at the origin, whenever we start plotting information, it's going to go up this way, but other possibilities are going to be the opposite of that. If you were to take this and rotate it over, it's going to be the same manner in the opposite direction, or the other upward direction, I should say. Does that make sense? So recognize whenever you have an absolute value, you will end up with a V. It's going to look like a V on a Cartesian plane. It may be sideways, it could be going down, but it's still going to have that V shape. So you can automatically understand what it should look like. And then on page 113, it kind of gives you an idea too, whenever you have an exponent, one of the forms that may occur. One thing that I want to point out on page 113 at the very top, we have the function of x when x equals 3 to the power of x. So we have to figure out values for x. And then the function of x equals y, so we're solving for y. Whenever I want to write this down. Be confusing just talking about it. Equals 3 to the power of x. In this situation, we're saying y equals 3 to the power of x. We are still finding values for x and solving for y. But our x values, it's an exponent. Okay, so we want to do 0 and 1. So you don't want to do 25 because then you have to do 3 times 3 times 3 times 3 times 3 times 3 times 3, 25 times. Okay? So because x value is an exponent. Now what happens is whenever you graph it, if you look at the page of 113, the top, notice it goes up, and as it comes down and starts going along the x-axis, it will never, ever, ever touch that x-axis. It gets closer and closer and closer to 0, but the decimal system, or the decimals become further and further and further. Okay, it never actually reaches true 0. All right? Cool. A couple more things. Um, 3.6. If we look at the example here, we are given two points whenever we have, there are basically two x's in this equation. So all we're having to do, if you see that h of x, which is going to be substitute for the letter y, okay, equals 3 to the power of x plus 3x, whenever you find a value for x, you will plug it into both of those x's and solve for y. Okay, you're not finding two separate values of x. Whatever value of x you choose plugs into both of those x's. Okay? One value for both x's. Does that make sense? And that is pretty much all you're taking what you've learned already and applying that into 3.6. 3.7 and 3.8. The only two things that I want to go over with those, because they're inequalities. Inequalities are done just like equalities. What is the one thing that will occur that's different than for an inequality than with an equation? There's one thing that you have to pay attention whenever you're moving stuff around from side to side. One thing you have to pay attention, one rule. What is it? It has to do with dividing by a negative number.
Oh, I've never seen that.
Yes. Whenever you divide by a negative number, let's say minus 3y is less than x. When you divide by a negative number, you must change the sign. You have to flip it. Okay? You have to flip it. Now, the other point that we need to make sure of with regard to inequalities is when we graph it. So here we remember our rule, whenever we divide by a negative number, we have to rotate the sign. Don't forget that because there will be those in there. When we graph it, if we have greater than or equal to, our line is going to be dotted. Okay? If it is less than or equal to or greater than or equal to, then it will be a solid line. Okay? And you're like, okay, well, we had an equation with an equal sign and it was a solid line, so what's the difference between the two? I'm really glad you asked. Because with an equation, everything fell on that line and only on that line. With inequalities, it is everything on one side of that dotted line or the other. Okay? One side of the dotted line or the other. If it is equal, greater than or equal to or less than or equal to, it will fall on that line and one side or the other. So there will be an area that's shaded. Okay?
She liked to bring that.
No. Okay, I'm sorry, I didn't hear it. That's okay, come on. So what this means is, if we have the dotted line, then it will be, the answer will be somewhere, say on this side, or it could be on this side. How do we know? How do we know which one it is? Well, if we have y is less than, say 3x plus 1. Find a coordinate point anywhere that is on one side or the other of the dotted line. And then what you're going to do is plug in the x for the x and the y for the y. Looking at this, what do you think is going to be the easiest coordinate point to choose? If you look at this dotted line and you're choosing a coordinate point somewhere on this side or this side, we're going to plug in that coordinate, the x value and the y value, we're going to plug it in. If this is a true, if it makes it a true statement, then you will shade in that area that you chose from. If it's a false statement, then it will be the other side. So looking at this dotted line, what coordinate point do you think would be the easiest to choose?
That'd be 0.
The origin, 0 and 0, right? So we can plug in y, 0 for y is less than 0 would be for x, so it's 0 plus 1, which is 1. Well, 0, is this a true statement? 0 is less than 1? Mm-hmm. Absolutely. So you shade everything that coordinate fell within on that side of the dotted line. Okay? Same thing if it's a greater than or equal to, it will be a solid line. But you still choose a coordinate point on one side or the other. If it ends up being a true statement, then you shade in that area. If it's a false statement, then you shade the other side of the line. Make sense? Easy enough? Awesome. Finally, last thing I want y'all to do is write this down. We have a few more minutes left and we will be done. Distance and midpoint. Distance, well, we've already talked about midpoints in the past, but understand this equation. Okay? We're showing this in our book. What I really want you to do is skip to this part. Okay. Remember this one. Whenever you're looking for distance, plug it into this equation. We're coming from originally here. The idea is if you have 2 points and they happen to land on whole numbers, you have this distance. You can actually use the Pythagorean theorem to turn this whole thing into a triangle and figure out distance. You can determine the distance just by adding the units from one point to another and say this ends up being 5 units from here to here. This is 4 units from here to here. So what is the distance between the two? Well, a squared plus b squared equals c squared. You solve for c. That's great if both of these points land on 2 actual points that are all whole numbers. When they're in between 2 numbers and they're fractions or parts, it's like 3.2, it makes things a little bit more difficult. So we can use this distance formula that you can plug in any of the information in and find out what that distance is between 2 points. Okay? What do you think is the midpoint?
The point in the middle?
Yes. Very good. How would you find that?
Would it be like the corner of the...
Well, if you're looking for the distance between here and here, and the midpoint is in the middle of it,
You have to find the distance and you can do the middle.
yes. If you find the distance, what do you do to find the midpoint? It's a really good question. Well, is that the midpoint or is that just half the distance? What is the point in which is the actual middle between those two?
You're saying like 4.5 or something?
Well, and that's the point I'm trying to make. Don't confuse midpoint with half of the distance. Because let's say this is 8. You found the distance is 8. The midpoint is not going to be 4. Okay? It's the point on the graph that lands on this line directly in between this point and this point. So, you're like, well, it would be so easy if there was like an equation or something that I could use to put all this together, right? Yes, what? What am I missing? It's all right. So, what we can do is this. It's very similar to it. All right, so the midpoint. If you were trying to find we'll just label it so we can be consistent with the book. The midpoint will end up being x2 minus x1 divided by 2. Okay?
It'd be MP, not PM.
So, hold on a second. No, y'all go ahead. Y'all like get it all out and just be done with it. So, because I'll go back and edit it. Everybody's like trying to hold it in, and
Okay,
so what's funny?
I don't even know why I did this, but so I look over there, okay? For some reason, I don't know, I just look over there. My hand's like right here, okay? And I just,
Is she doing the same
so
thing?
stupid.
Oh.
She did like this.
Oh.
I was like my face was straight. I was like,
Well, at least she didn't go
funny.
and like hit somebody in the back of the
and then
head.
we just kind of, and then, yeah.
Yeah.
Okay.
That's what usually happens.
All the time.
All right, so let's do this. And honestly, because I'm trying to rush through this, and we need to actually be done, but this is really, really important. So I want to get this down. Let's just do this example real quick, example number 2, and it will end up making more sense. It's telling us to find the midpoint of a line segment with endpoints 5, 2, and -4 and 0. 5, 2, and -4 and 0. Now, what we're going to do is we have x1 and y1, x2 and y2. Label these for the time being till you get used to seeing this, because we have 5 and 2 and -4 and 0. These are the points that we're looking for. So we have x1 and y1, our first coordinate points, 5 and 2, x2 and y2, -4 and 0. Now we can plug them in where we have x1 plus x1 plus x2 divided by 2. And then we have y1 plus y2 divided by 2. Now what that does is that gives us the actual coordinate point. So we'll plug these in. We have x1, which is 5, plus a -4, so -4 divided by 2. And this is all one big coordinate point. Then we have our y1, 2, minus 0 divided by 2, which gives us 1/2 and 1. Now that is our coordinate point that will be the midpoint between those two original points. Does that make sense? I think this was easier just to do this example than it was to try to explain it. Make sense? Cool. Label them out so that you don't confuse them. Plug them into here. Okay? Don't forget, if you want to, put that comma in there so you know that you're dealing with 2 points within one ordered pair, and then find out what it is, and that will be your midpoint for that segment.